Hi everyone, my name is Maddie and I'm from Massachusetts. Today, a group of girls and I are going to be talking about dimensional analysis as the first lesson in our chemistry unit. We're excited to be here with you. The first topic in this lesson will be significant figures, where we'll learn how and why we report numbers with a certain degree of precision. The second topic will be units of conversion, where we'll learn how to convert between different units, as well as some common metric prefixes and standard units used to describe measurements. Third, we will discuss temperature, including Celsius, Kelvin, and what temperature means on the particulate level. And last for today, we'll talk about density, including how it relates to states of matter and how to calculate it. We'll follow the lessons up with a density lab and a dimensional analysis lab. Let's get started.
Hi everyone, my name is Caitlin and I'm from Massachusetts, and today I'll be discussing significant figures. So significant figures are the digits in a number that give this number accuracy and precision. When you're doing math or measuring something, you want to make sure that the numbers you're using are as precise as they can be while still being accurate. So you want them to be as exact as possible. So this is why we use significant figures. So what exactly are significant figures? What are zeros at the end of a number? So if you have the number 100, the last two zeros, because they're at the end of the number, would be called trailing zeros. And trailing zeros are not significant unless there's a decimal point in the number. So the number 100, the trailing zeros, are not significant unless you add a decimal point and say 100.0. This makes all three trailing zeros significant. All right, now that we've gone over what counts as a significant figure, when you're measuring something, you need to know how many significant figures to use. So, when you're measuring, you want to count all of the accurate digits you can, and then round one last digit. So, for example, you're measuring something with a ruler, and you can see that it's definitely 5.3 centimeters, and then a little bit more. You can look at this and say 5.3 and round the last digit to maybe 5.34. Because the last digit is a little bit more than 5.3, but you can't tell exactly where it is. So when measuring something, count all of your accurate digits, all the ones that you know to be true, and then round the last digit, and that'll get you the right number of significant figures. All right, the last rules are for adding, subtracting, multiplying, and dividing numbers. So for adding and subtracting, you're going to do the math out in full. And then you're going to round to the least precise place. This place is going to be furthest to the right, or all the way at the end of your number, in your starting numbers. You always want to go back to your starting numbers when you're rounding at the end of doing math. So let's say you have the numbers 12.5 and 10, and you're adding them together. 12.5 plus 10 is going to get you 22.5. Now we have to make sure that that is the right number of significant figures. So we go back to our starting numbers and see that we have 12.5, whose least precise place is going to be 0.5, and 10, whose least precise place is going to be 0. Out of the two numbers, the 10th place in 12.5 is going to be our least precise place. So we want to make sure our answer is rounded to the 10th place. And 22.5 is rounded to the 10th place, so we know that our answer has the right number of significant figures. All right, next for multiplication and division, it's somewhat similar. You do all of the math out in full, but then instead of rounding to the least precise place, you round to the least number of significant figures in your starting numbers. So let's do an example. Say you have the numbers 10 and 18, and you want to multiply them together. 10 times 18 gets you 180. But when you're going back to your starting numbers to figure out, but then you have to go back to your starting numbers to figure out what the least number of significant figures is. So you have the number 10, which has one significant figure, and you have the number 18, which has two significant figures. So the least number of significant figures in the starting numbers is 1. Now we have to make sure that our answer only has one significant figure, but 180 has two significant figures. So we have to round 180 so that it only has one significant figure. So now, in the right significant figures, 10 times 18 is equal to 200. Hi everyone, it's Caitlin again, and today I'm going to be talking to you about units of conversion. These units of conversion are needed when you're doing unit analysis, which is the mathematical method of converting measurements from one unit into another unit. When you're referring to a measurement of any type, it's going to be in a unit, depending on what you're measuring. For instance, if you're measuring in distance, the common metric unit is meters. When you're measuring a mass, the common metric unit is kilograms. For time, it's seconds. For temperature, it's Kelvin. And for electric current, it's amperes. Now, these units tell us what the number we're looking at is referring to, whether it's a time, a mass, a distance. So it tells us a lot about the measurement that we have in front of us. These units can also be expanded upon, or they can shrink depending on a prefix that we put in front of a unit. So in front of you, you have a table with a list of different prefixes that can be put in front of one of the units. Let's do an example. For instance, let's take centimeters. Centi is the prefix, and meters would be the common metric unit. That makes centimeters. We know that centi, it says, is 2 to the negative second, which means it's 1 over 100. So if we have centimeters, that means we have meters divided by 100. So a centimeter is going to be 1/100th of a meter. And this is now a new unit that we can use, or a different shaped unit that we can use to help us measure something of a smaller value. So all these prefixes let us measure something of either a really large value if we want to use mega or giga, or a very small value if we want to use micro or nano. So let's learn how to convert from one unit into another. There is an equation that is in front of you, and it's the given amount in the given unit, and you multiply that by a fraction of the new unit over the given unit, where this fraction has to equal 1. And this answer is going to give you the amount that you want, but in the new unit. So let's do an example to try and explain this. We'll have 20 kilometers, and let's say we want to convert that into centimeters. 20 kilometers is our given amount in our given unit. Now we need to multiply that by a fraction of the new unit over the given unit. The given unit is kilometers, so let's put 1 kilometer in the denominator. Now in the numerator, we have to put something in centimeters. That's going to make this fraction equal to 1. So we need to figure out how many centimeters are in 1 kilometer. And we can do this by looking back at this chart here to see the difference between kilo and centi. So we can figure out that in 1 kilometer, there is 100,000 centimeters. Now, we can multiply this equation out, and it gets you 20 kilometers times 100,000 centimeters divided by 1 kilometer. Now, we're trying to multiply different units here, but in reality, we have a kilometer in the numerator and a kilometer in the denominator. So those are going to cancel out, and you're going to be left with 20 times 100,000 centimeters over 1, which gets you 2 million centimeters. So we know that 20 kilometers in centimeters is equal to 2 million centimeters. All right, that's all for units of conversion. I hope you guys enjoyed.
Hello, I'm Grace from Massachusetts, and today we'll be talking about temperature. First, I'll talk about what temperature is, and then I'll move on to discussing how to convert between two units of temperature. Temperature is commonly defined as the amount of heat present in a substance or object. But how does an object become warm, and where does that heat come from? A better definition for temperature would be the measure of the average kinetic energy of a substance's particles. The faster these particles move, the greater the kinetic energy in an object, so the warmer the object is. The same is true if the particles are moving slow. The slower the particles move, the lower the amount of kinetic energy in the object, so the less heat the object has. Kinetic energy is the amount of energy an object possesses due to motion. For example, if you rub your hands together, your hands will start to feel warm because the energy from you moving your hands is transferred to heat energy. There's a point in this process where the particles are moving so slow that the kinetic energy is at its minimum amount. This means that no more heat can be removed from the object, because the kinetic energy amount cannot be any lower. This point, where the temperature is the lowest it can possibly be, is called absolute zero. Next, I'll discuss how to convert between two units of temperature. The two units of temperature I'm referring to are Kelvin and Celsius. Celsius is the unit of temperature used commonly throughout the world, and Kelvin is the unit of temperature that is usually used in science. To convert Kelvin to Celsius, subtract 273.13 from the given Kelvin value. To convert Celsius to Kelvin, add 273.15 to the given Celsius value. For example, if we start off with 300 degrees Kelvin and we subtract 273.15, we will get 26.85 degrees Celsius. For a second example, if we have 20 degrees Celsius and we add 273.15, we will get 293.15 Kelvin. The graph in the bottom right corner of the screen shows the values where water will freeze and boil in both Celsius and Kelvin. It also shows the point in which absolute zero is reached, also known as the lowest possible temperature, where the kinetic energy level cannot be any lower and no more heat can be removed from the object. That is the end of my presentation. Thank you for listening and watching, and I hope the information you learned here today was helpful.
Hi guys, my name is Liv and I'm from Massachusetts, and today I will be talking a little bit about density. So the first thing we need to discuss is what I mean when I say density. Density is simply the measure of an object's compactness, or how much mass there is within a certain space. We express this measure of density in grams per centimeter cubed or grams per milliliter. Both of these can be used to express density because 1 centimeter cubed is equivalent to 1 milliliter. Centimeters cubed is typically used when talking about solid objects, and milliliters are typically used when referring to the density of liquids. It's important to remember that although different substances may have different densities, every sample of one specific substance will have the same density. Although water and oil have different densities, every sample of water will have the same density, just as every sample of oil will have the same density. For example, if you have 2 cups filled with the same substance, we will call it substance A, and you take a sample from each cup to calculate the density of each sample separately, you will end up with 2 calculations that prove the samples have equivalent densities. It's important to remember that the states of matter will affect the results when calculating the density of a substance. I will talk to you guys a little bit about the 3 basic states of matter: solid, liquid, and gas. I want to remind you guys that when a substance moves between states of matter, the total mass of the substance does not change, but the amount of space that the substance occupies does change, and this affects the density. In the solid state, the substance typically has tightly packed particles, so its volume will take up less space and seem smaller. When calculating the density, you will see it has a higher density. In the liquid state, particles move a little bit more freely and take up a slightly larger volume than they did in the solid state. This will make the density for the substance slightly lower. In the gaseous state, the particles of a substance are constantly moving and bouncing off each other, causing it to take up the largest volume and have the lowest density. To calculate the density, we are dividing the total mass of the substance by the total amount of volume that it takes up. So now, when we wonder, how did the states of matter affect density? We know it is because when the states of matter of a substance changes, even though the mass of the substance is staying the same, the amount of space that that substance takes up is changing. This also allows us to understand that one substance can have 3 densities based on which state of matter it is in, but only if it can exist in all 3 basic states of matter, because some substances cannot. So next I have a lab for you guys to try, and for this lab you will need oil, any kind of cooking oil will do, water, and any transparent container because we want to be able to see the results of the lab. So you can pause the video and collect your materials. First, we will begin by filling your clear container about halfway full with water. Then add a few drops of oil at a time to your container with water in it until you see a thin layer of oil form. I want you to look at your container and notice which liquid is floating on top. And using what we just learned about density, think about why this might be happening. You can pause the video to discuss. After letting the oil settle, I hope you notice that the 2 liquids separate themselves. The oil particles naturally take up more space than the water molecules because they are not packed as tightly together. This means that a specific volume of oil will weigh less than an equal volume of water. This allows us to understand that oil is less dense than water when we plug it into our density formula. Just to summarize the things I talked about today, I want you all to remember that the density is a measure of how closely packed the particles of a substance are. We record this measurement in grams per centimeters cubed or grams per milliliter. This is because every substance has a density based on its mass and volume, which changes depending on the substance's state of matter. The state of matter affects the volume because it changes how compressed the particles are. If you guys want more practice with density, there's a link below which will take you to a website that has more examples and practice problems.
Hi again, my name is Maddie, and for this lab we're going to practice converting in between different metric units. You will need a meter stick or tape measure to measure your step. Use your measuring tool to record how many centimeters one step walking is for you. It may be easiest to do this if you work with a partner. There's a chart on the next slide that you may copy into your notes and fill in with your calculations. Pause this video to copy down the chart into your notes. Then use the procedure you learned earlier in the lessons to convert your measurement into a value for each unit and place it in the chart. Using the chart you filled in on the last slide and conversions between distances and steps, pause the video again and answer the questions above. The most important takeaway from this lab is that dimensional analysis principles hold for any unit. You can do these conversions with units of density, temperature, length, and more. Any questions you may have, please feel free to reach out to us, and we look forward to seeing you in the next chemistry video soon.